So in order to predict products of reactions, the first thing you need to do is decide whether it's a single replacement reaction, where you've got a compound plus an element. That element is going to kick one of the elements out in the compound, and we're going to end up with a new compound and an element from the compound. In a double replacement reaction, we've got a compound plus a compound, and we end up with two new compounds. Here, you're going to use your activity series and make sure that that metal can kick the other one out. Here we're looking for a precipitate, so we want one of our compounds to be a solid using our solubility chart. So let's look at some practice. So again, here's just the activity series. This is for your single replacement reactions, and you're going to use it to figure out the one that wants to do the kicking out has to be further over this way. Solubility chart for our double replacement reactions, and we're looking for any that end up with a solid. If we end up with two aqueous solutions at the end, we have no reaction. So let's look at some practice. So the first one, we've got an element plus an element. This is going to be a synthesis reaction, which is one that we're not too worried about here, but we're going to end up with magnesium oxide, charges on this guy, +2, -2, so they're going to cancel, balance this reaction just for good practice. 2 magnesium oxide, so we got to go over here and get that 2 magnesium. Next practice. Potassium plus water. So we've got an element plus a compound. This means that this is going to be a single replacement reaction. So now we got to look at potassium's charge to figure out whether he's our cation, our positive, or our anion. So who is he going to kick out? So potassium is +1 on the periodic table, so he's a cation. So he's going to kick out the positive in the compound. So hydrogen is a plus, oxygen is a minus. So potassium is going to try to kick out the hydrogen. And the way that we can figure out if this is going to work, we look at our solubility chart. Or not our solubility, our reactivity chart here. So let's look at our activity series. So we're going to find potassium here. So potassium is here, and hydrogen is over here, meaning that potassium is more reactive than hydrogen, so he's going to be able to kick him out. So let's write our new compound. It's going to be potassium and oxygen. We're going to end up with an ionic formula, so we've got to look at our charges on the periodic table. Potassium is coming from group 1, so his charge is +1. Oxygen is in group 16. His charge is going to be -2. You're going to crisscross those charges. That 2 is going to come over here to potassium, and the 1 is going to go over to oxygen. Now we're going to have that hydrogen. And remember, hydrogen is a diatomic, so we're going to end up with 2 hydrogen. And then if you want balancing practice, 2 potassium over on the product side, we need 2 to start with. Following the law of conservation of mass, now this is a balanced reaction. Our next practice, we've got a compound plus a compound. So this is going to be a double replacement reaction. So here we're going to be looking for a precipitate to be formed. So let's figure out what our products are going to be first. So our positive is going to end up with the new negative, and the anion on one side is going to end up with the cation on the other. So let's label our cations and our anions first. So potassium we just looked at in our last reaction, so he's positive, so he's going to be a cation. CO3 is one of your polyatomic ions, and he's an anion. are negative. Barium is your metal, so he's going to be positive, and calcium is a nonmetal, so he's going to be negative. So the potassium and the barium are going to switch places here. So we're going to end up with KCl, K's charge +1, chlorine's charge -1, so they're going to cancel. And then we're going to have barium carbonate. Barium is in group 2, so his charge is +2. Carbonate's charge is -2, so those charges again are going to cancel. But I still don't know if this reaction is going to happen, so let's go to our solubility chart. So to use the solubility chart, we're going to find our first element, potassium, and potassium is in group 1. So I'm going to go over on group 1 and figure out where he meets up with chloride, and chloride is in group 17. So where do those crisscross? This is going to be aqueous. So now let's look for barium and carbonate. So we're going to find barium, and barium is in group 2, and he's not magnesium and he's not calcium. So we're going to look at this column, or row, and then we're going to find carbonate. So carbonate is here. So those match up right here, and it's going to be a solid. So we indeed have a precipitate formed, which means that this reaction is going to happen, and it's a double replacement. I hope this has helped you in your single and double replacement reactions.